Hello, my name is Charles Yoon. I work for JIVE in the Netherlands. JIVE stands for the Joint Institute for VLBI in Europe, and my project is called NEXPReS. And NEXPReS is Novel Explorations Pushing Real-Time eVLBI Services, and I hope I got that right. What we do, we're radio astronomers, and what we do is we take radio telescopes that are distributed around the planet at continental distances, so not only in Europe, but in Australia, in Asia, South America, and these telescopes will point up at the sky and look at the same object in the sky, and they take all of the data that they're gathering from this object and they stream it back to my location in the Netherlands, where we have a supercomputer that we call the correlator. The data is sent to us at very high data rates, so we use advanced networks, we use light paths, we use specialized routing, we use specialized protocols to make sure that we can saturate the networks, because the more data that we can send to the correlator, the better the quality of the images that we'll be able to generate afterwards. At the correlator, the supercomputer calculates, processes, correlates formally all of the data, and it produces a result. What the NEXPReS project is doing is actually moving forward a little bit and saying, why do we need to build and maintain a single hardware correlator that will actually age over time, and it won't improve, and it won't take advantage of Moore's law. So what we're going to do is we're going to take advantage of some of the advantages of Moore's law by having distributed computing, build a software correlator that will actually be more flexible, that will allow us to do things and change things as we suddenly realize scientifically, oh look, the correlator with a minor adjustment would be able to provide better results or more interesting feedback. A hardware machine, it's very difficult to do that. With a software machine, it's a simple process of adding more software, of writing new code. So it's complicated, but it's not impossible. Once you have a distributed software correlator, you then have to worry about things of more advanced networking, of bandwidth on demand, light paths that need to be brought up, established, and then torn down so that you as a single user community are not eating up a very scarce resource that's distributed across the world. It's a shared e-infrastructure, and you want to make sure that you're sharing it. And once we have that in place, we also are working on a storage element. And what we want to be able to do is take this data that's being sent to us from the different telescopes, sometimes, if necessary, or if desired, buffer it onto these storage units. And this is not just like a normal hard drive, because obviously it's going to be big. We have telescopes streaming data currently at 1 gigabit per second, but going to 4 and then to 10 gigabits per second. But we want to be able to simultaneously read and write at 10 gigabits per second to these storage units, and have these storage units be distributed around the planet as well. So we're working on all of these things together, and we hope that this will make NEXPReS not only a successful project in and of itself, but something that actually helps build science as a whole.